you can see that it's 1 Michael, put 2 Michaels together, and then 3 Michaels. Okay, let's get rid of that one, and you have a hop, You see, we've made a measurement. Now, the SI actually uses this kind of thing. That's 2.875 Michaels. We've gone from this standard thing by doing quantitative comparison. We've made measurements out in the real world, and that is how measurements actually, even in the SI, that's how they work. So we can do time as well. So we can just count Maxwell's, throw a ball up in the air, count the number of pendulum oscillations. It took 5 Maxwell's. Let's just do that again. There we go. Up in the air. 5 Maxwell's. Now you might be thinking, that's not very accurate, because it's quite a long period, in the same way that the second is quite a long time actually. But of course, we then just make a smaller pendulum, which counts deci-Maxwells. And that one took 52 deci-Maxwells, that's 5.2 Maxwells. So you can see now we can measure more and more precisely. And in fact, you know what, you can make them smaller and smaller and smaller. You can make them the size of atoms. And then you've got really, really high frequency tick-tocks to time things against. And that the Mick and the Steph. And you can put those together to begin to measure more complicated things out in the world. So, for example, here's speed. So that ball is going to shoot across the screen, and it's going to shoot across the screen here. And when it goes past the first line, the clock will start. When it goes past the second line, the clock will stop. So here it goes. So, whoa, fantastic. 1.1 Maxwell's it took. And that's 2.875 divided by 1.1 Michaels per Maxwell. Now, my system of units is very, very thorough. I've put a lot of effort into this. And so we've got abbreviations for these units, and that's called a Micromax. So, in the SI, they've got rules for, did you remember Ian said 10 to the power 14 and 10 to the minus 1? When you divide by a unit, you put minus at it. So for meters per second, they say meters per second to the minus 1. I think it's really rather an ugly thing. In my system, you just put O in front of it. Micromax. I think it... So there you get speeds from each little clock stopping and starting. So we get a table of speeds, and we can work out accelerations. That's 0.413 Micromax a max. And you can work out forces. You can stretch this thing a very long way. And that is my system of units. And I want to recommend it to you. There's the Sharmila, that's the unit of force. The Andrew, that's the unit of torque. Any of you who have met Andrew will know exactly why that's the right name for the unit. And the Insyuk, which is the unit of pressure, the force, that's the number of Sharmilas per square mile. My system of units, I hope you noticed that the names are gender balanced, and they're also ethnically diverse. But perhaps you've spotted something wrong with my system of units. Can anyone think of anything wrong with my system of units? Oh, damn, you've got it first time. Only I know it. That's right, no one else uses it. And you might think, well, that's very nice. But the point about systems of units is their specialized language for communication. In the same way that philosophically you can't have a private language, it's nonsensical, in the same way you can't have a private system of units. And when we use units, they're not for our convenience or for my aggrandizement, they're actually to communicate with other people. And so it needs to be a shared system to work. Now there are a couple of other weaknesses also shared with many other unit systems. The first one is that thing I put first one is that thing I pointed out. The standard Michael or Stephanie could get damaged, and then it might change its length or weight. And this has happened to every unit system that has been created. At some point over a few hundred years, the fundamental standard objects that have been created have been damaged, often destroyed. In the UK, the standard pounds and yards were destroyed at a House of Commons fire. So this is a real risk. The second thing is we're trying to use the units for two different things. If you've got a standard unit, like I said, you want to keep it perfect and put it in a safe, don't touch it. But on the other hand, that stops you making copies of it. And then you think, well, you'd have a secondary standard, but then that's not the standard. It's a secondary copy. So you've got to make up your mind. There's this conflict there. And the last thing is the standard values are just completely arbitrary. Now, the reason that I have wasted 10 minutes of my precious time here to talk about my system of units is I want to communicate to you that all system of units, just like my system of units, are made up. We just make them up. We invent all those words that you're familiar with, the meter, the kilogram, the Kelvin, all these things. People have invented them for particular reasons, particular conveniences. They have a history, but they're invented by people. And that's why I use this ridiculous example. Okay. So let's get on to the International System of Units. Now, these are the base units of the International System. There are 7 of them, and we sit them round a table like this to try and show that they're somehow of the same status. They're like the United Nations. There are some that are bigger and more powerful than others. So they differ dramatically in the concepts they use for realizing the units, but there they are. And there are lots of things right with this. So the thing that's most right is that everybody uses this system of units. It is humanity's universal system of measurement. And it's in the name. The clue is in the name. It's the international system of units. It's not called MKS, it's not called the imperial system, the British system. It's the international system. And this international agreement is at the heart of how it works. Some of you might be thinking, wait a minute, don't Americans still use pounds or something? And you know what, since the 1960s, well, they still do use pounds, but since the 1960s there have been no standard pounds. A pound is just a fixed fraction of a kilogram. And
ありがとうございます。じゃあ07の D でお願いしますね。俺の再開中です。お願いします。
assembled for a family reunion in Paris. And they're all compared to the Remember when you put your children up against the thing with the wall and how big? Oh, you've grown.